want us to have a look at a graph question. Graph questions are gifts if you get them on the exam paper. Now, if you're asked to construct a graph, the first thing I want you to realise is when you've got your information here like this, in the first column of your data, that is usually your independent variable. That is the thing that you are controlling and you are setting the range and the increments. So you're going to place that on your x-axis, and your y-axis is based on your dependent variable, which is in the second column. So first column on the x-axis, second column on the y-axis. If you get a graph like this, then you should be realising there's something wrong. So here's a graph that another student did. It's much better. What they've done is they've taken the whole of the column heading and they've placed the whole heading on the y-axis. And they've done the same with the y. Now this is what we want to do. In biology, we cannot have labels that are too long. We can easily have them that are too short when students are paraphrasing this and writing it here, but we just keep the whole of the heading and we place it on the appropriate axes. The second thing we need to do is we need to make sure that we use crosses. We don't use dots, and the whole reason of doing that is because the examiner needs to see where you have placed your crosses to check that you've plotted them in the right place. If you use dots, then they are hidden by the line that you draw. So in science, in biology, always a cross. Your crosses have to be at least half the size of one of the squares on the grid. If they're too small, it's basically a dot. So make sure that they are discernible, that we can actually see them. The next thing is you need to choose your scale carefully. Now this is touch and go. Basically what we want is we want any line drawn on a curve to fill at least half the space of the graph paper. So this, I don't think it does it really. Actually, in year 11, we'll be hammering home the fact that you need to choose your scale here appropriately. We don't need all of this 10 and 20 because our first value starts at 26. We need to be choosing it so that our curve actually takes at least half the space on the graph paper. And the last thing to note about this is that we do have in biology S-shaped curves that signify something starts off very slowly, something increases really rapidly, and then something levels off. However, if your exam question has asked you to draw a curve of best fit, a curve of best fit can be a straight line, or it can be a curve of best fit that best applies itself to the points that you've plotted. I think in this instance, you can see it's very clearly an S-shaped curve, and so drawing them up with a nice smooth curve is the best way to go. Graphs are gifts. We can see in this instance that there are 3 distinct phases to this graph. So we can see that here is 1, here is 2, and this one is phase 3. Okay, if we're asked to draw conclusions from this graph, then what we would look at is these 3 distinct areas. In the first area, we would say up to 50 kilograms per hectare, there is very little increase on the yield. From 50 to 125, there is a large increase in yield, and beyond 125, there's very little increase in yield. Boom, there we've got a description. We've not tried to explain it, we've just recognised that there's 3 phases of this graph, and we've described the impact of this on this. Bingo.